whenever x1 is less than x2, the functional value is less than or equal to each other. That is, f of x1 is less than or equal to f of x2, then we say that the function is increasing. The derivative of the function is used to determine whether the given function is increasing or decreasing at particular point or at the given interval or completely throughout the domain. F is increasing in the interval minus infinity, minus 2 and 3, infinity, and it is decreasing in the interval minus 2, 3. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are in the chapter Applications of Derivative. In our previous session, we have learned one of the important application of derivatives, that is rate of change of quantities. And in this session, we are going to learn how the derivative helps us to find whether the functions are increasing or decreasing. So here we are dealing with increasing and decreasing function. So when you look at the curve, f of x is equal to 1 by x square. So the curve will be in this form. So clearly you can see from point 0 towards the positive side of x, the function is clearly increasing. And when you come from the left hand side to 0, the function will be clearly decreasing. So this is how. And at a particular interval also we can calculate whether the function is increasing or decreasing. So we can verify whether the function is decreasing even at the interval, even at the complete domain or at particular point also. Now let's see what is increasing and decreasing function. Let I be an open interval contained in the domain of a real valued function. So we are completely taking the domain and we are taking one particular interval I. Then f is said to be, then the function is said to be increasing on interval I if there exist two variables x1 and x2 in the interval such that whenever x1 is less than x2, the functional value is less than or equal to each other. That is, f of x1 is less than or equal to f of x2, then we say that the function is increasing, and we call it as strictly increasing if x1 is less than x2 such that f of x1 is strictly less than f of x2. Remember, here we have equal, less than or equal to here. So here it is a slack inequality and here it is a strict inequality. So then we call here it is strictly increasing. And for the same condition, it is said to be decreasing if for all the values of x1 less than x2, if f of x1 is greater than or equal to f of x2, we call it as a decreasing function. And similarly, if f of x1 is strictly greater than f of x2, we call it as a strictly decreasing function. And there exist certain functions which are neither increasing nor decreasing. For example, you can see the graph of sin x, cos x. They will be increasing at particular point and it is decreasing at particular point. When taken it as an interval, it is neither decreasing nor increasing function. Now let's see the graph of these type of functions here. So clearly, I have taken many examples of graphical representations of the function below. So this is an example for increasing function. See, it is increasing at certain point, it may be constant and then it may increase at particular interval. So this is an increasing function and here it is strictly increasing function. There is no break inside the graph here, it is clearly increasing. So decreasing function you can take as example. So for certain interval it may move towards and then it may decrease again. So then this is an example for strictly decreasing function and here is an example for neither increasing nor decreasing function. So I hope you get an idea about all these type of increasing and decreasing functions given below. Now as I said, whenever the points exist inside the interval, if x1 is less than x2, based on the conditions f of x1 greater than f of x2 or f of x1 is less than f of x2, we can decide whether the given function is increasing or decreasing or it is neither increasing nor decreasing. So here is an example. Let's verify. Show that the function given by f of x is equal to 3x plus 17 is strictly increasing on R. So whenever we have taken a real valued function, so we have to take two values. x1 comma x2 belongs to R such that x1 is less than x2. Then we have to verify whether f of x1 is less than or equal to f of x2. Since here is strictly increasing, here it is enough to show that f of x1 is less than f of x2. So now let us consider x1 comma x2 belongs to R. Now here consider x1 is less than x2. So multiply 3 on both sides. So then this implies 3x1 is less than 3x2. Then add 17 on both sides. This implies 3x1 plus 17 is less than 3x2 plus 17. What is 3x plus 17? It is f of x. Then this can be implied as f of x1 is strictly less than f of x2. Remember, for all x1 comma x2 belongs to R, we have taken x1 is less than x2 and we have arrived at the condition f of x1 is less than f of x2. So therefore, what we can conclude here, f is strictly increasing on R. So similarly, we can show that whether the given function is decreasing or strictly decreasing. Now, as we are talking about the application of derivative, how we can identify whether the given function is increasing or decreasing with the help of derivative. Note that here the derivative of the function is used to determine whether the given function is increasing or decreasing at particular point or at the given interval or completely throughout the domain. Let's see now how it helps us to find. So here is a theorem. Let f be a continuous on closed interval a comma b and it is differentiable on closed interval a comma b. As I already said, since we need the derivative, f must be a continuous function because every differentiable function is continuous. So therefore, f is a continuous function on the closed interval a comma b and it is differentiable on the open interval a comma b. Then f is increasing on the closed interval if f dash of x. So whenever any function is given in the form of y is equal to f of x, find out f dash of x. F dash of x is nothing but dy by dx. So find out its derivative. Whenever the derivative gets a positive, which is a positive quantity, then we say that it is an increasing function. Whenever f dash of x is less than 0, that is if it's a negative quantity, then we call it as a decreasing function. Whenever it is equal to 0, for what values the derivative becomes 0? Only for the constant function. That is why whenever it is exactly equal to 0, we say the function is a constant function. Hence, f is increasing if f dash of x is positive, f is decreasing if f dash of x is negative, and it is a constant function if f dash of x is equal to 0. Now let's take out the problems and find whether the given function is increasing or decreasing with the helps of derivatives. Show that the function f given by f of x is equal to x cube minus 3x square plus 4x for x belongs to R is increasing on R. So given here f of x is equal to x cube minus 3x square plus 4x. Now find out f dash of x. F dash of x here 3x square minus 6x plus 4. So next here I'll take f dash of x is equal to 3x square minus 6x. I'll write 4 as 3 plus 1. So here I'll take 3 as a common factor. It becomes x square minus 2x plus 1 plus 1. So here it is 3 into, so this can be taken in the form of x minus 1 whole square plus 1. So this is our f dash of x. Clearly we know that square of any quantity is positive, 3 is positive, 1 is also positive. So clearly we got f dash of x is greater than 0, which is a positive quantity. So therefore what we can say, f is increasing on R. So just by verifying whether the f dash of x is greater than 0 or less than 0. That is whether it is a positive quantity or negative quantity. We can verify whether f is increasing or decreasing. Next question. Find the intervals in which the function f given by f of x is equal to 2x square minus 3x is strictly increasing, strictly decreasing. So first, let us find the derivative of the function. F of x is 2x square minus 3. Let's find out f dash of x. F dash of x is 4x minus 3. So to find the interval of a function, put f dash of x is equal to 0. So we get 4x minus 3 is equal to 0. This implies x is equal to 3 by 4. Now write down the interval for x is equal to 3 by 4. Suppose this is the number line. So here is our minus infinity value and this is our plus infinity value. And this is the point 3 by 4. So clearly you can see here the interval is minus infinity comma 3 by 4 and here it is 3 by 4 comma infinity. So therefore clearly you can see here. So for all x belongs to the interval 3 by 4 comma infinity, here we get f dash of x which is equal to 4x minus 3 is greater than 0. So clearly you can see for all the values between 3 by 4 comma infinity, if you substitute here, it's a positive quantity. So therefore, f is increasing in the interval 3 by 4 comma infinity. Next, here for all x belongs to minus infinity comma 3 by 4. Clearly you can see f dash of x which is 4x minus 3 is less than 0. If you substitute 3 by 4 here it is 4 get cancelled, 3 minus 3 which is 0, and below that value if you take any other value it is clearly a negative value. So therefore f is decreasing in the interval minus infinity comma 3 by 4. So once you find the point, divide the number into two intervals and verify taking any point such that f dash of x becomes 0, such that f dash of x becomes greater than 0 or less than 0. So considering that interval, you can say whether it is increasing or decreasing function. Next, find the intervals in which the function f given by f of x is equal to x square minus 4x plus 6 is strictly increasing and strictly decreasing. So same as the previous one. So here let us find out f dash of x. F of x is x square minus 4x plus 6. So f dash becomes 2x minus 4. So put f dash of x is equal to 0. So we get here 2x minus 4 is equal to 0. So this implies x is equal to 2. Now let us divide the interval on the number line. So here is a point minus infinity and this is 2 and this is plus infinity. So divide the interval. So clearly you can see here f dash of x is equal to is 2x minus 4. So any number less than 2, suppose if you take 1, it will be 2 ones are 2 minus 4. So any number less than 2 will give you only the negative quantity. That is, so for all x belongs to the interval, which is that interval minus infinity comma 2, f dash of x which is 2x minus 4 is less than 0. So therefore, f is decreasing. Next, now here for all x belongs to the interval 2 comma infinity, that is 2 and after 2 if you take any quantity which is a positive quantity and you substitute here, absolutely it will be less than 4 and then hence when you subtract it will be a positive quantity. So therefore here f dash of x which is 2x minus 4 will be greater than 0. Therefore, f is increasing. Next, find the intervals in which the function f given by f of x is equal to 2x cube minus 3x square minus 36x plus 7 is strictly increasing, strictly decreasing. Now f of x is given. Let's find out f dash of x. F dash of x is 3 2s are 6x square minus 6x minus 36. So here put f dash of x as 0. So we will get 6x square minus 6x minus 36 is equal to 0. When you divide this equation completely by 6, it is x square minus x minus 6 is equal to 0. Now here, so when you take this, we will get the factors as x plus 2, x minus 3 is equal to 0. So this implies x is equal to minus 2 and x is equal to 3. Now here we have 2 points. Let us divide the intervals in the number line. Now here is our number line here. It is plus infinity, minus infinity. Somewhere here we have minus 2 and here is 3. So we can divide the number line into 3 intervals. So what are the intervals we can have here? So from minus infinity to minus 2, from minus 2 to 3 and from 3 to infinity. Now how to find out whether the function is increasing or decreasing at these intervals? So we'll make a tabular column here. So first we will write down the intervals here. Next here in this column we will write sign of f dash of x. So what is the sign of the intervals inside here? So next here we will decide the nature of the function. So now let's see here. Let's write the first interval. So minus infinity, minus 2. Here both are minus. Hence the value becomes positive in f dash of x. So therefore here it is increasing. And let's write the second interval, that is minus infinity comma 3. Here 1 will be negative and 1 is positive. So it is negative. So clearly it is decreasing. And the last interval, that is 3 comma infinity. So both are positive here. When you substitute the values, hence it is positive. So therefore it is increasing. So therefore f is increasing in the intervals. So the first interval is minus infinity comma minus 2 and the 3 comma infinity, and f is decreasing in the interval minus 2 comma 3. So thus we can clearly say f is increasing in the interval minus infinity comma minus 2 and 3 comma infinity, and it is decreasing in the interval minus 2 comma 3. Next question, find the intervals in which the function is given by f of x is equal to 4x cube minus 6x square minus 72x plus 30 is increasing and decreasing. Let us find out f dash of x here. So f dash of x is here 12x square minus 12x minus 72. So here when you put f dash of x is equal to 0, so here it becomes 12x square minus 12x minus 72 is equal to 0. So divide throughout equation by 12, we get x square minus x minus 6 is equal to 0. Thus the factors we get is x plus 2, x minus 3 is equal to 0. So this is same as the previous one. Thus here also we can clearly divide the interval from minus infinity to minus 2, minus 2 to 3 and 3 comma infinity. So these are the 3 intervals we get. We will write all these 3 intervals here in the first column, and the second column here we will decide the sign of the f dash of x. So here we can clearly see from the intervals f dash of x is both are negative and hence it becomes positive. Whenever f dash of x is positive, the nature of the function is increasing, and here it is negative and positive, so therefore negative. F dash of x is negative, which is less than 0. That means the nature of the function, that is decreasing, and here both are positive and hence it is a positive quantity. Therefore the function is increasing, and hence for this function f of x is equal to 4x cube minus 6x square minus 72x plus 30 is an increasing function in the interval minus infinity comma minus 2 and the interval 3 comma infinity, and it is decreasing in the interval minus 2 comma 3. This is how we are going to identify the nature of the function, whether it is increasing or decreasing, by knowing whether the derivative of the function is positive or negative or 0. If f dash of x is completely 0, it is clearly a constant function. If it is a positive, then it is a increasing function. If it is negative, it is a decreasing function. We will meet you in the next session with another important application of the derivative. Until then, keep watching, keep learning, keep exploring. Thank you.